Welcome to our video on finding the domain of a function algebraically. So let's review what we know about the function notation, okay? So recall that if we want to find f of 8, okay, we want to take 8 and plug it in everywhere there is an x. And that gives us the square root of 4 over negative 3. And we can do that. The square root of 4 is 2, and we have negative 3. If we want to do f of 2, okay, that gives us the square root of 2 minus 4 over 5 minus, oops, 5 minus 2, which gives us the square root of negative 2 over 3. Well, that creates a problem because we can't take the square root of negative 2. So we've noticed that 2 is not possible. Okay, so f of 4, well, that would be the square root of 4 minus 4 over 5 minus 4, which is the square root of 0 over 1, which is just 0. Well, that works. What about f of 5? Well, that would be the square root of 5 minus 4 over 5 minus 5, which would be the square root of 1 over 0. And again, we can't divide by 0. So 2 and 5 are not possible. So 2 and 5, for some reason, these two here are both excluded from the domain. Of square root of x minus 4 over 5 minus x. Okay, so we can see that we might have some problems here. Okay. So I'd like for you to take a moment and answer this question here. What caused us to have problems in that example? So out of these 5 options here, A through E, what gave us a problem? Which one or ones gave us a problem? So domain exists in the world of real numbers. And this is where we end up having restrictions on our domain. Because we always start the domain with the set of all real numbers. All right. Then if the equation has a denominator, we exclude any numbers that make the denominator equal 0. So take a moment. Why? Now, if the equation has a radical of even index, okay, so we are just talking about square roots, okay? then the expression, we want to exclude any numbers that cause the expression inside the radical to be negative. So take a moment and tell me why. Why do you think we have to exclude those numbers? Now, in this case, when we're looking at this example here, we have f of x equal to 1 over x squared minus 4. This function is not defined when the denominator equals 0. So we can say that x squared minus 4 cannot equal 0, which means that x squared cannot equal 4, which then means that x cannot equal positive or negative 2. Now this is linear. Okay? And when we have any linear function, there are no values of x that would create a problem. Any value of x that we put in there is going to create a real number. So we are good. Okay? Now in h of x, here we have a square root. Okay? And we know that the expression, we call this the radicand, the expression here, just this expression, has to be strictly greater, it has to be greater than or equal to 0. So we set up 4 minus 3x has to be greater than or equal to 0. Okay? We can subtract 4 from both sides. And we get negative 3x greater than or equal to negative 4. We can divide both sides by negative 3. And remember, when we divide or multiply by a negative, we have to flip that inequality. So x has to be less than or equal to 4/3. So any value of x that is less than or equal to 4/3 will create a true statement. We are going to actually skip this one for now because we have not covered factoring quadratics. But we are going to move on to our next example here. Okay. And our next example, we have a couple of things going on here. We have a denominator. Denominator cannot equal 0. We have a square root. And what's under the square root must be greater than or equal to 0. But if it's greater than or if it happens to be equal to 0, then it messes with that. So that means that our radicand can only be greater than 0. Okay? Now here, we have the denominator cannot be equal to 0. Here, we have the square root, and remember, what's under it has to be greater than or equal to 0. And that can stay because like the denominator doesn't affect the numerator as to what we can and can't do. So we have two separate things going on here. We have that 6 minus 3x has to be greater than or equal to 0. So negative 3x greater than or equal to negative 6. So x has to be less than or equal to 2. And then we have x squared minus 81 cannot be equal to 0. So x squared cannot equal 81, and x cannot equal positive or negative 9. Well, now we run into a little bit of an issue, at least for me. My brain doesn't see these abstract things like this very, very well. So what I like to do at this point, I like to draw a number line. I'm going to put 0 here, and it does not have to be accurate. I'm going to put positive 2 here. I'm going to put positive 9 up here. I'm going to put negative 9 here. Okay? And I am going to start out with this piece here. X has to be less than or equal to positive 2. So I would have a filled in circle, and then we would have everything down here. Okay. Now I'm going to take a look at this. X cannot equal positive 9 or negative 9. So I would have like an open circle here and an open circle here. Okay. So in the end, the domain is only where these two things intersect. Okay. So remember that square bracket means that we touch, parenthesis means that we get close, but not quite. So you would have everything from negative infinity to negative 9, but that negative 9 is going to get a parenthesis because we're not going to touch it. We're going to get close, but not quite. We union that with negative 9 up to positive 2 with our bracket. And that is going to be the domain of that function. And here we have a quick summary of all of these rules. So you can see if we have no fraction, no even indexed radical, our domain is everything. If our function does contain a fraction, we set the denominator not equal to 0. If it contains an even indexed radical, we set the radicand greater than or equal to 0. If the function contains a fraction with an even indexed radical in the denominator, then the radicand is strictly greater than 0. And if the function contains a fraction with an even indexed radical in the numerator, the denominator is not equal to 0 and the numerator is greater than or equal to 0, and find the areas of intersection on a number line. And I have included an example for each one of these.